This is section 1.7, and this is going to be our video part 1. And we are talking about the combinations of functions and also composite functions. Today's video will focus on the domain of functions and also combining functions, and these are all targets on your target sheet for chapter 1. So let's talk about the domain of a function. Now we've found domain often from graphs. Now we're going to be finding domain from equations. So just a quick reminder that domain is your possible x values that will work in the equation. Now you could graph these onto your graphing calculator, and then you could take a look at the graph and use your knowledge of finding domains from graphs to help you. Or you can go through the process I'm going to go through today, and you can find the domain using the equations. So let's take a look. You can see here we've got 3 examples we're going to look at, and we have 3 different things happening. The first example, we have a fraction. The second one is square root, and the third one, it looks like we don't have anything like that. We just have squares and multiplying. Now, looking at the fraction example first, we need to think about fractions for a minute and what we know, and basically when we're looking at this, I want to know where will the problems occur. In a fraction, the problems occur when the denominator, the bottom, is equal to 0. So we know that the domain can be anything except whatever number will make the bottom 0. In order to find the domain here, we'll take the bottom, the denominator of our fraction, and set it equal to 0. Let's find out what that number is. I'm going to subtract 2 from both sides and divide by 3, and we end up with negative 2/3. Now negative 2/3 is the x value that will make the denominator 0. If I plug that in there, I'm going to get a 0 in the denominator, and I don't want that to happen. So, because that's the number that's going to make the denominator 0, that's the number we're going to have to exclude from our domain. We can't let x be that number. X can be any other number, though, except negative 2/3. So using our interval notation, we're going to say, you know what, let's go from negative infinity to negative 2/3. But I'm going to put a parenthesis there to say I can't be 2/3, negative 2/3. If I'm negative 2/3, we'll be 0 in the denominator. That won't work. We'll put our union sign, and then we'll just jump right over it. So we'll start right back again at negative 2/3 and go all the way to positive infinity. So you can see here we're going to have every x value except negative 2/3. Something's happening at the graph at negative 2/3. We're not sure what yet, but something's happening there, either an asymptote or a hole. There's a problem at negative 2/3, so we have to jump over it for our possible x values. Now, taking a look at the middle one, now we have a square root graph that we are going to find the domain of. Now, if you think about square roots for a minute, square roots have problems when they're negative underneath. So that means that the thing underneath can't be negative. If it can't be negative, then we're going to say that thing underneath, 4x minus 1, has to be positive, meaning it has to be greater than or equal to 0. Now let's solve this and figure out what x's will make this true. What x's will make 4x minus 1 greater than or equal to 0? If I add 1 to both sides, I get 4x is greater than or equal to 1. Divide by 4, and we get x is greater than or equal to 1/4. Now in this case, this isn't the numbers we're going to exclude. This is all the numbers that will work. These are all the things that will work. Any number greater than or equal to 1/4 will work under that square root. So this answer is our domain. Now, if we're using inequality notation, you really could just leave your answer just like that. If we're going to use our interval notation, we're going to say let's start at 1/4, so we'll put a bracket. And we're going to end at positive infinity because that represents everything greater than or equal to 1/4. And that would be our interval notation for the domain. So again, for square roots, you're going to find where the thing underneath the square root is greater than or equal to 0, and that answer is your domain. Now let's take a look at our last example we have here. In this case, we have lots of multiplying and exponents happening, x squared minus 7x. And if I look at everything happening there, there are no places where I could have a problem. I can get answers no matter what I put in for x. There are no fractions or square roots to worry about. So in this case, we would just say negative infinity to infinity. Our domain is all real numbers. Let's review that really quickly, what we just talked about. So, if we're finding the domain, and we have a square root, let's start with, where did my page go here? Alright, try again. If we're finding the domain, from an equation, the first thing is if we have a fraction, we know the denominator cannot equal 0. So in order to find the domain, if we have a fraction, the first thing we'll do is set the denominator of the fraction equal to 0. We'll solve. This is the answer that we have to exclude from our domain, take out. If we have a square root, remember, the underneath, the thing under the square root, has to be greater than or equal to 0. So in this case, we're going to set the under greater than or equal to 0, the thing under the square root. We're going to solve. And in this case, the answer is our domain. It is the things that will work. And if we don't have fractions and square roots, then usually there's no problems that'll occur and we can have negative infinity to infinity. Alright, let's move ahead to objective number 2. Now, you don't need to write all these down. I think they're pretty intuitive, so just follow along right now in your video and then you can decide. This is going to be a target. And this deals with combining functions. And basically the rules are as follows. If you are trying to combine functions with adding, you can just add those two functions together. Just like if you want to combine two functions by subtracting, you can just subtract the two functions. Multiplying works the same, and dividing is also the same. But notice here that the g of x can't be 0 because we can't have a 0 in the denominator. So let's just go ahead and work through some examples. Here's the first example. We have two functions, f of x and g of x, and we want to find f plus g of x. So we want to add those two functions together, f plus g of x. Our rule from the previous slide said we just need to add f of x and g of x together. So let's go ahead and do that. When I add those together, I get 2x minus 1 plus x squared plus x minus 2. Combine like terms, 3x plus x squared minus 3 would be your final answer. Continuing to the next example, we are going to find f minus g of x. So now we're going to do the same thing, but now we're not adding, we're subtracting. It's really important here when you write down your second function, for example, the g of x that we're subtracting, that you make sure to use parentheses because we want to remember that we're subtracting all of those things. I'm going to go ahead and distribute the negative sign. And I can combine like terms now, and we get, it looks like a negative x squared, 1x, and positive 1 as our final answer there for f minus g of x. Now for x times g of x, we're going to multiply these two together. Remember that to use your FOIL option, I'm going to go ahead and I'm going to draw a rectangle to multiply these together. I'm going to have 2 pieces times 3 pieces here. So we're going to end up with 6 boxes. So I'm going to put 2x minus 1 and x squared plus x minus 2 there. Why don't you go ahead right now, pause your video, multiply these together, and let's see what you come up with for an answer. Hopefully you came up with 2x cubed plus x squared minus 5x plus 2. Alright, and lastly, dividing. Now the first thing we'll do is just write these as a division problem. So we'll say 2x minus 1 over x squared plus x minus 2. Now we'd want to look for any simplifying that can occur at this point, and I'm going to look and see if x squared plus x minus 2 factors. So I can use my diamond and my rectangle, however you want to factor. We're looking for 2 things to multiply to negative 2 and add to positive 1. So we've got 2 and negative 1. So I know this factors into x plus 2 times x minus 1. Now looking at the top, nothing's going to cancel out here, so the factoring really didn't get me any further. So now I know that the answer was just what I started with, 2x minus 1 over x squared plus x minus 2. This is where we're going to end our video for today. In tomorrow's video, we'll start talking about the domains of these, and hopefully already leading a little bit into tomorrow's video, you're thinking about this last example that we just talked about, and you're thinking about the denominator, and you know already that there are some numbers we're going to have to exclude from the denominator. We'll start with that tomorrow. Let's make sure that we look at our questions for the day today. Our free response question here, you're going to find the domain of this fraction. You may have to do a little bit of factoring there in the denominator to figure out what's going to make that 0, just a hint. And your multiple choice question, you are going to find f plus g of x for those given functions. Go ahead and bring those responses with you tomorrow in class after you put them into the Google form, and we will talk about them tomorrow.